Okay, this is problem 11. It's also a problem that Mr. Staples got wrong. So let me see if I can move this where you can see the answers and everything. Okay, here we go. All right, well, number one question, we got to read through the problem. In the figure above, lines K, L, and M intersect at a point. If x plus y equals u plus w, which of the following must be true? Okay, now let's just slow down for a second. So we got these lines. Here, let me get my pen here. Okay, so here's this one line. Okay, here's this other line, and then here's this other line. Now the key in this problem is the figure is not drawn to scale. That tells you that you're going to have to be very careful. All right. Well, let's see. Let's go with what they said. They said u plus y, x plus y, that's this right here, is equal to u plus w, u plus w. Okay, those are equal. U plus w. Okay, well, one thing we do know, I'll just write this right here, x plus y is equal to u plus w. We know that y is equal to u, right? Vertical angles, y is equal to u. Y is equal to u. If I subtract that, I find that x is equal to w. Y is equal to u, and x is equal to w. If x right here, let me get it done another color, okay? Okay, if x is equal to w, okay, these two angles are equal to each other. Now wait a minute, isn't w equal to this angle? It sure is, vertical angles. Isn't x equal to this angle? Yes, okay. Now, we know that y is equal to u, but we don't know if y is equal to x, so please keep that in mind. Now, which of the following must be true? Let's look at number one. The way to do these problems is to answer these in order, okay? Separate your thinking, do them in order. X is equal to z. Is x equal to z? Yes, we know that. Is y equal to w? No, we don't know that. And is z equal to t? Well, yeah, right here, z is equal to t. We know that for sure. Now, that indicates that only 1 and 3 are correct. 1 and 3. Now, you're looking down here at the answers. Now you're trying to pick the answer. 1 and 3. That's right there, answer B. Now, these problems can be confusing. And like I said, this is one that I messed up on. It's because I did the wrong method in solving it. But I showed you a method that works, and I hope that helps you out. Okay, let's look at this problem. In the quadratic equation above, all right, now quadratics, remember quadratics are graphed either like that way or like that way, okay? Also, don't forget on a quadratic, wherever the graph crosses the x line, that's a root. So if that was 2, a factor is x minus 2. Keep that in mind. In the quadratic equation above, a is a non-zero constant. The graph of the equation, the xy plane is a parabola with vertex at c comma d. Now that's very important. The vertex is at c comma d. All right. Which of the following is equal to d? So it's wanting to know what the y value is at that point. Now, incidentally, whenever these are plotted on the coordinate plane, this is the line of symmetry right here. That root and that root, you take the midpoint of those two roots. That's the x value here. This x value is always in the middle. All right, now with that in mind, let's go to the problem. Here's a quadratic. What is one root? 2. 2 is one root. What's another root? -4. -4. Now, it wants to know what the y value is at the vertex. Well, let's find the x value. We got to add these and divide by 2. What is negative 4 plus 2 divided by 2? That's negative 2 over 2, which is negative 1. So the x value is negative 1. Now what we're going to do is we realize that if we plug in negative 1, we should get the y, all right, which is d. So let's see. We got a, we don't know what a is, but we got negative 1 minus 2. And then I got negative 1 plus 4. So that's going to be a times negative 3 times 3. And what is that? That's negative 9a. Negative 9a would be the y value at C. So this is the answer we're looking for. Negative 9a right here, answer A. It's one way to work that problem. Okay, the equation blah is true for all values where x is not equal to 2 over a, where a is a constant. You really kind of don't need all of this here. We kind of all understand that. Okay, what's the value of a? The question is actually, can you solve this equation? That's a good question. Well, one thing we could do is we could multiply both sides of the equation by the common denominator, which is ax minus 2. When I multiply the left side by ax minus 2, they wipe out, and I got 24x squared plus 25x minus 47. Okay? Then on the right side, I've got this binomial right here times a minus x. Let me write it over here. Ax minus 2, that is, times ran out of room, negative 8x minus 3. Okay, and don't forget I got this minus this guy. So these guys would wipe out and I have minus 53. So that's going to go here and then minus 53. All right, let me rewrite this. 24x squared plus 25x minus 47. Okay, we're going to have to multiply that right side out. When I multiply that right side out, what do I have? Well, I have negative 8ax squared. Now notice here it's saying what's the value of a? Well, I don't really have to finish this problem. I know the x squared term on the right side is going to be this. I don't even need the rest of this. So I know the coefficient of the x squared term here has to equal the coefficient of the x term here. Or negative 8a is equal to 24. So a is going to be 24 over negative 8, or negative 3. Negative 3 is answer B, the correct answer. Okay, question 14. What are the solutions to blah? Well, one thing I notice right away, that 3 goes into everything. So let's divide everything by 3. X squared plus 4x plus 2 is equal to 0. That helps out. Another thing we need to do is, now we're stuck. We can't factor, so we're going to use the QF, quadratic formula. Okay, how does that go? Well, there's a sum. X is equal to, but before we sing this song, remember, this is A, this is B, and this is C. So here we go. X is equal to negative B plus or minus square root plus or minus square root b squared minus 4ac. Now a times c is 1 times 2, which is 2, all over 2a, which is 2. Now essentially we're done, but what we're going to have to do is we're going to have to simplify this a little bit more. So let's see, what is that? 16, right? Minus 8, okay? Now 16 minus 8 is 8. So negative 4 plus or minus radical 8 over 2. Radical 8, you got to simplify that radical. It's 2 radical 2. So negative 4 plus or minus 2 radical 2 all over 2. Now there's 8 ways to do this. I would just split it right up here. It's negative 4 over 2 plus or minus 2 over 2 radical 2 over 2. That's negative 2 plus or minus radical 2. And which answer choice is that? A. Question 14, the correct answer is A. That's how you do that problem. Okay, this is one of these thinking problems. Here's the way I would approach this. It's really about that chemistry formula about temperature. Okay, now let's do this. Do you agree if the temperature was 32 Fahrenheit, that would be 0 centigrade, and if the temperature was 33 Fahrenheit, that would go up by, the centigrade would go up by 5/9, because that would be 33 minus 33 is 1. 1 times 5/9 is 5/9. So for every increase of 1 degree Fahrenheit, the centigrade would go up 5/9. Okay. Now, what if the centigrade went up 1? How much would the Fahrenheit go up by? Well, if I multiply this little deal by, well, I could solve this equation, but I'm not going to do that with time. I'm just going to go 9 over 5F. And that's related to a C. And what that means is, as 1 degree Celsius goes up, the Fahrenheit goes up by 9 over 5, or 1.8. Okay, I probably could have explained that better. All right, so now that we get the gist of how this works, let's look at the possibilities. 1, a temperature increase of 1 degree Fahrenheit is equivalent to a temperature increase of 5/9 degrees Celsius. That's true. A temperature increase of 1 degree Celsius is equivalent to a temperature increase of 1.5 degrees Fahrenheit. That's true. A temperature increase of 5/9 degrees Fahrenheit is equivalent to a temperature increase of 1 degree Celsius. I'm trying to trick you right there. No. Okay. The reason why we know that is we know that an increase of 1 degree Fahrenheit gives the 5/9 Celsius degree, and we also know that the Fahrenheit is bigger than the Celsius, so that would be another reason why that's not right. Anyway, so now we're looking for 1 and 2. 1 and 2. 1 and 2 is D right there. Correct answer.